Hey everyone, in this video we're going to talk about integrating Phantom Wallet into our Solana smart contract. Hi, my name is Josh and this channel's mission is to accelerate the world's transition to blockchain technology. So that said, let's talk about what we're going over today. So overview, we have 5 things we want to do. First, we're going to install the Phantom Wallet. 2, we're going to learn a bit about React because all of the integration UI that's available to connect with wallets are all in React. Then we're going to learn about the Phantom Wallet adapter, React libraries specifically. And then we'll get the Anchor IDL that's generated from an Anchor project. And then finally, we're going to implement the front end using the Anchor IDL to talk to our Solana network. A quick introduction, what is Phantom Wallet? Well, quite frankly, I'm actually very surprised if you made it to this video if you don't know what Phantom Wallet is. But just a quick summary, Phantom Wallet is a crypto wallet that makes it easy and safe for you to store, buy, send, receive, and swap tokens and NFTs on the Solana blockchain. The link is in the description below on how to install it. We will need to do that for this video. Of course, this video will also cover other wallets, but Phantom is probably the most known wallet, which means it'll probably show up on the YouTube search engine more often, so that will help me get views. So that's why I say Phantom. So as always, sponsored by no one, because no one wants to sponsor me. So big thanks to myself for making my playlist. Like always, I try to make these videos independent of each other, but there are some knowledge that you can kind of glean from each other. A big one in this video might be learning how Anchor works. Moving on, disclaimer as always, not development advice. We're actually getting closer and closer to the point where we might actually do something dangerous. In this video, we'll be writing the front end to send transactions to our smart contract. So be careful what you write out there. So finally, let's get started. So first thing we need to do is we need to install the Phantom Wallet. It's a Chrome extension. I'm not going to install it. I think it's pretty straightforward. Go to the link, install it. Not too bad, I hope. Then step 2, we need to learn about React. So what is React? React is a JavaScript library, essentially, that essentially you can think of as create modular HTML elements, so to speak, and we'll see more about this if you don't know what I mean. And each of these HTML components has code that it can interact with other components, so it helps you keep your code very modular and easier to collaborate with a bigger team. So let's take a quick dive into it. Here is a very quick sample example that I pulled up about React. So first we have a function called app. This is a app component specifically. And you can see that it can use in the second arrow at the bottom. The syntax for those familiar with HTML, which I hope is everybody here, is very similar to just any normal HTML element like a button or a div or paragraph and so on and so forth. And that's all React essentially is. All these functions and class that we create, they're just HTML components that has their own underlying logic. So if we actually look inside the content of our function, it returns essentially this gobbledygook of HTML elements. It's a div wrapped inside these header, main content, and footer HTML elements. And for those familiar with HTML, you should know that all 3 of these are not real HTML elements, at least with the capitals anyways. So taking a quicker look into header, the first HTML element, you can see that header actually is another function that is a React component. Inside the header component, we see that it returns an actual HTML header. This is a native header. And inside that, it has another React component called add, and we have our basic image and h1 tags. So that's essentially what a React component is. And so now, adding a bit more complexity to what we know about components, React also has a concept called props. As you know, for example, image source, you can include your source, your class name, and alt tags. We can do something very similar with React components. We can define something called props, or probably properties. These are variables that can basically be anything. In this example, there's a message. There's a component called hello message, and it has a prop called name, where you pass in a string. In this instance, it's Taylor. And you can access the prop by just calling the curly braces, and then this dot props, which is the keyword, and then the variable that you passed into the component, which in this case is name. Next up are the event listeners. You can click event listeners such as on click, on focus, on touch, and things like that onto your component, and then they will execute code. In this case, if you click on the button that we define right here, it will execute the handle click function that we pass in. We don't really need to worry about the code in this specific video. But if you are interested in a more full depth React video, please leave a comment below and I will put down my backlog of things to do. So that is a very quick highlight of React. We don't cover everything, but that's, I think, enough for us to have a rough idea to understand what is happening. That's actually a lie. We'll actually be tossing like half that knowledge we learned away in the trash can, but best we got. So now that we have mastered React, it's time to move on to using some React libraries. So if we want to detect a wallet on our browser when we visit a specific Solana application, we need to use the Solana wallet adapter library. And it's basically just a simple library that has three purposes. Well, probably more, but three purposes for this video. Set up the connection to make a transaction. For example, like who should you connect to? Is it the local host, your DevNet, mainnet, and so on and so forth? Second thing is to get the wallet information from the user. There's a lot of support. We'll talk about more about this later. And finally, provide a reusable UI component for common behavior. And those are in the form of a React component. So the first thing is the one we're interested right here is the Solana wallet adapter React. It contains helper functions to store your wallet information and your connection information. We'll dive into that later. Next up is the actual wallet adapter. So these are all the wallets that your application will support. As you can see, we have Phantom right here, and this is what we will be using. But there's a lot we can use to support if we want. And then finally, we have the React components. Solana has created multiple libraries with different UIs to match whatever style that you're going for. The one we'll be working with will just be the first one, just the wallet adapter React UI. So now that we roughly understand the three pieces to this library, or it's actually multiple libraries, but to this GitHub repo, let's actually start looking into some of the code and make sense of it before we actually start using it. We'll be looking at a starter project, specifically the Create React App Starter project that is included in the wallet adapter GitHub repo. And it's just an example, nothing fancy about it. You can clone it and play with it yourself. In fact, we'll be using it for this video. So to kind of go over the code, the first entry point will be the index.tsx inside the source folder of our project. And the code isn't anything too surprising, I would hope. We have this app component that we use, and we'll see where it's defined. And this is where it's defined, actually. So app, and you see this weird syntax where it says fc equals parentheses and returns function. This is something called functional components. Don't worry about it. Just kind of accept that it is what it is. The important part is the syntax for our HTML is still the same. So inside our app component, we call two components, context and content. And here they are. Here's where they're defined. The middle one is context and the right one is content. So we'll quickly take a look into context first. So when we're first looking at context, the first thing we notice is that it takes in a parameter called children, and children are essentially the components that's wrapped inside our component. So in this case, if we look at our app function, context has a child component of content. So in this instance, our children refers to the content component. And then we use this passed in content, as you see right here, and use it in the bottom arrow, where we just pass the component down to another component, or we could render it there if we wanted to. So moving on, the first part of our code is we need to set up the network. This is where we want to connect to. I included the link to the code, but essentially there are three networks that's already predefined for us: mainnet beta, testnet, and devnet. In this video, actually, we're going to define our local host. We can actually do that. It's just a string. So we'll be using that to talk to our local host when we deploy our smart contract. Now, the network is used in three places. The first one is where all these use memo. And what memo is memoization. For those not familiar, it's basically caching our results based off our certain inputs that we give it to prevent heavy computation. Honestly, I believe in this case, it's kind of redundant. Like, I guess optimization is good, but I feel like it's kind of overkill. Anyways, moving on. Number two is to get the cluster URL from this helper function provided by another helper library, the web3.js from Solana. If you read the documentation of the cluster API URL function, it just returns a string that is the URL that we are connecting to. And then finally, the third use of the network that we define, it's just a value that we pass into some of our wallets. They need the instance of the network, so that's all. Speaking of the wallets, we need to define our wallets, and this is where we define them. We create an array of that we call wallets, and inside this array, we just include a list of all the wallets that we want the users to be able to interact with. And that's it. And finally, this is the more complex part. We're going to use React context, specifically these providers you see right here: connection provider, wallet model provider, modal provider. And essentially all they are is they're just kind of global fields that can be accessed in any child components. Based off of what we talked about props earlier, we have to keep passing the variables in. Nothing gets carried over unless you explicitly pass it in. So that's where context comes in. And the context just allows any component to access these fields that you set up with your provider. But the quick TLDR is always just copy and paste this code. It's pretty much the same every single time. But anyways, diving into some of this. So we have our connection provider. If you look into the code, this is where the component is used, and this is where the component provider is defined. And if you actually look into the code a bit, you can see that the component provider returns a connection context. And a connection context is defined in this other class. Specifically, it's where you use it. You call this function use context. And what use context does is it returns this connection context class, which is actually used up here when we set up our provider. So what we're really doing here is, in this code, we're passing in variables. We're storing it inside this connection context. And then whenever we want to access it, we just call this, we import this helper function called use connection. And then use connection will allow us to access this field globally, anywhere in any child components. And of course, if we're curious about what is inside the connection context, here's what's defined. It just contains one field and just the connection. Now, next up, we have the wallet provider. Wallet provider is more complex. There's a lot more code, so I'm not going to go into it. But we can see that it contains its prop, which is what we're passing in over here. The two of the notable things is wallets, so the wallets that we're connecting to, and auto connect, and then should we automatically connect to the wallet. And of course, if we're curious about what use wallet returns, we can look at the wallet context state, which is right here. You see there's quite a bit of things. You can read more about it if you're curious. So before we move on to talk about the wallet model provider, because that's actually in a different library, let's step back a bit and look at all of our UI libraries. So these are where the components are mapped to. And inside both of these files, our content and context component, we have components that are defined from the wallet adapter React UI. And what this library is, to reiterate, it's just a library that allows you to create easy UI that looks good and adds a lot of additional functionality that you don't need to implement yourself to connect a wallet in your app. So looking at some of the code, the wallet modal provider is used to set visibility and it's specifically used by the UI components like the wallet multi button. You yourself might not ever need to use it, but some of the underlying components that you use might. And at the very bottom, this is just a quick snapshot of what it looks like. So pretty slick UI, and you didn't have to do a thing. So now that we actually know how to set up our component, let's actually see how we can use it. So this is some of the code that might go inside the content component. This was just another code snippet that I just took from the repo itself. In any child component that we're in, like our content, for example, we can use the context to retrieve the user's connection and wallet information, and we can use that to send a transaction. As you can see in these arrows right here, we call these two helper functions that we imported, use connection and use wallet, and we just deconstructed the object that we get back into the fields that we care about. And for completion's sake, let's just look at our onClick event listener. So we define an onClick function, and we can see that we use some of the variables that we imported. For example, the send transaction function is used right here. The public key is set right here, and so on and so forth. And this onClick function that does all that is set to this button that we define right here. And so whenever the user clicks on that button that's defined, this code will execute. All right, we're making great time. We might actually finish this video in less than 20 minutes. So to be able to implement our front end, we need to have a backend. And for the backend, we're just going to keep it simple, and we're just going to reuse an existing Anchor project. Specifically the Anchor project that we created in our last video. But for those who are new to the video, you can just clone the existing Anchor project we used and just follow along. The code is almost like 99% identical. And a quick introduction for those who don't know what Anchor is. Anchor is a framework that is created by Project Serum, another big project in the Solana ecosystem. And what Anchor does is it simplifies all the problems that you might encounter when writing a Solana smart contract. Specific things like serializing, deserializing data across the network, doing automatic checks for your code to make sure the senders are who you think they are, and so on and so forth. Do check out my past video about this if you're curious. So here are the instructions. Clone the repo. We go to the specific project that we're interested in. We do yarn install, Anchor build, and then use Solana address to get the address of your program, which is very important because we need to put that back into the code itself so we have our environment set up correctly. And then we build it again on step 7. Step 8 fits somewhere along this step. We also need to update our anchor.toml with the new address. And then finally, we have all of that. We can do Anchor deploy. All right, so let's get started on setting up our Anchor project. We're doing this because we need to get the IDL JSON file, which will be used in the front end. Once again, for those new, one powerful thing Anchor does is it creates a JSON object that can be used on the front end to essentially create helper functions that you can call that will talk to the Solana network for you without needing to do anything. All right, so I'll just pull up a new Visual Studio. We're going to open a folder. Okay, so I'm not in my WSL instance. So for those who are new to the video, there's quite a bit of setup that needs to be done, unfortunately. So do look at the past videos. Essentially, a quick recap is you need to install WSL if you're on Windows. If you're on Mac or Linux, you're completely fine. Well, I'll just show you. Open the command prompt. So in here, we need to go to a WSL instance. And I'm just going to the root directory. And in here, we can see we have all sorts of folders that we've used throughout the video. And we just need to do a git clone, and we just include the Anchor project. Once we have that set up, we can go to Visual Studio Code, my choice of editing, and then use the WSL extension to remote into it. Remote WSL is what it's called. And we'll just create a new WSL window to use the extension. Go to open folder, and this will allow us to select our WSL instance. So from all the past videos, you will know that I keep everything inside the video folder and then Anchor. So for those for the first time, you would just git clone that repo and then just go to this directory. And the reason why we're using WSL, if you're curious, is you cannot actually deploy a smart contract on Windows, so you need to run it on a Linux instance or Mac, which also runs Linux. Anyways, okay, so now that we are here, in the past video, we've updated this basic example to basically imitate the raw Solana code that we wrote in another previous video. But if you didn't do that, it's fine. Most of the code will be exactly the same. We included 4 functions that we use to process our instruction in our code. We have initialize, update, increment, and decrement. I don't remember what the original code was, unfortunately, because I edited this, but I think it has an initialize and increment. So all of this would be very similar. And we're going to go through all use cases, so you'll be able to copy and paste just fine. So now that we're here, it's important that we do a couple things. So first, we need to go to our basic folder. That's cd examples tutorial basic 1. We do a yarn install to install our dependencies. I already have it. And then once we have this, you just need to build your code. So that would be Anchor build. So we built it. And now that we built it, you can see that we have this new key right here. This is very important because this is the address to our program. So if we go back to this slide, we need to run this command to get the address of our key. And we get this. As you can see, it's all the same as what we've already set up because we did that in the previous video. But essentially, we just take this address and replace the existing address in our declare ID macro with our new one. And we go into our anchor.toml. We have this programs.localnet. This is just our local host. And we want to set the address to be that same one that we just created. Once we have all of that set up, we just run Solana or anchor build again to create a new instance. And then once we have all of that, we can just run anchor deploy to actually deploy this on our network. So I had this fail on me in the past, so let's see what happens. Okay, it failed, and the reason is because the localhost is not up, which is honestly quite odd because in our past videos, you know that it just worked. But we need to run our Solana network manually. So I just click the plus to create another instance of our bash inside our VS Code. And we just type in, okay, test validator. I guess I was right the first time. And this will start our local instance of our Solana node. I'll just run the background. So while we let this continue run, we can do anchor deploy again to deploy our smart contract on the network. And it's very important to actually do anchor deploy. Okay, so it's deployed. And so the most important part now that we have done all of this, is we accomplished two things. First is we put our smart contract on our local network, so our front end can now talk to it. And second important thing is we generated a basic one JSON, or the IDL specifically. And it's important, I found out this the hard way. If you run anchor, you need to run anchor deploy, otherwise this specific field will not show up. The importance of this IDL JSON object is that this is a format that the front-end anchor library can use to create helper libraries, helper code to connect to your smart contract that was deployed using Anchor. We need to move this into our front-end project, but before we do that, let's do an overview of what that entails. All right, so right in the front end, we will be using the Create React App Starter project that we went through earlier, and we're just going to modify it to use our Anchor IDL to talk to our smart contract on our local network. So we get clone to get the repo. We're going to navigate to that project, and there's a lot of projects inside this repo, by the way. And then once we're in that project, we will use the generated IDL.json that we created, our basic one.json from the Anchor project, and we're going to just create a copy of it on the front end. And then we'll do an npm install to get all our dependencies, npm start to kind of run an example, and then we actually start implementing our code. I just want to say there was a very helpful resource that I've used. This link right here, move my head. Also included in the description below. There were some things that had problems, but we fixed it. No big deal. So let's get started. So back inside our command prompt, let's make this bigger. Let's clone that repo. So we go to cd video. That's where we keep all of our stuff. And so we'll just do a git clone on this wallet adapter. It will actually be quite big because there's a lot of additional libraries that we're installing. Fine. All right, done. So we see our wallet adapter. Go to wallet adapter. Go to the packages, and if you just take a quick look, actually, you can see that we have our core helper libraries, like for the context and wallet connection stuff. We have the starter folder, which contains all of our example code to look at. There's UI, which is the reusable React UI components, like the buttons that we're using. And then the wallets, which includes the adapter to connect to our wallets that we want to support. So back to starter. Inside here, we want to go to the React App Starter. These are all the same. I'm just more familiar with the first one, so that's all. And now that we're here, we just need to install our dependencies, and then we can just run the application. So this one will really take a while. All right, so now that we're done installing, here we just do a npm start, and we'll start a application locally. All right, I have another instance of it. Let's close it. Let's do npm start again for real this time. So here we go. As you can see, on my top right corner, I already have Phantom Wallet installed. Because in this code example, we had auto connect set to true, the code would automatically try to connect to our wallet. And so I just unlock it and I'm connected. One thing to mention, if you open your Phantom wallet, that you need to go to your settings and go down here to change network. You gotta make sure that you are on your local host because that's what we're working on this project. So now that we're connected, and that's really it, and this is what this button does. As you see, you can copy the address, you can change your wallet to any other options that we've defined, and you can also disconnect and reconnect. And that's it. That's all this code does. And I'll make sure to make this bigger so we can all see it. I shouldn't have done this on the command prompt. I actually want to open this up in our project. So I will go back to Visual Studio Code and open another WSL instance, because in my code, this is all on WSL. So we go back to open folder, video, and then we'll go to wallet adapter, packages, starter, create React app starter. And we just open our folder on this specific project. So like always, we can go to view and hit the control squiggly line to open the terminal. That's always super helpful for us. And we can just do npm start again over here to start instance. One nice thing I always love about front-end development is if you go to, let's say, app.tsx, and we go all the way to the bottom in our code, is all the changes are hot loaded, so it automatically gets reloaded on the front end. So I can write something like, make a new button, and I'll say my cool button, and immediately this should reflect, and there you go, the UI changes. So very cool, very powerful. So let's actually get started on our front end. Get rid of this so we can see better. So all this code we've kind of went over already. One thing I didn't show is us importing these files. As you can see, these are where all the adapters that we were calling in the examples are coming from. We just imported them from the appropriate libraries that they came from. But one thing we do need to do is we need to create the IDL JSON file that we're going to consume. So we go back to our Explorer. Inside our source, we'll just create a new file and we'll just call it IDL.json. Inside here, we'll just go back to our other project, which is right here. Take our basic one JSON object, the IDL that we created, copy it, and just paste it over here. And so now in this code, we just need to import the JSON object, and we'll just call it import IDL from this directory, and we just want the IDL JSON. And that's really all you need to do to get the object. There is something wrong with this, and from this importing, we'll talk a bit about it later. And so I will just go straight to the code. We already know all of what this code does. We've talked about this previously. So we'll just go straight to our content component. This is where we're going to implement our code. And so for the sake of all of our time, I'm just going to copy and paste. First, we're going to get our provider. In the examples that we went through, we set up a connection context right here at the endpoints. But in this instance, it's not going to be used because Anchor, I believe, works differently. It takes in different things. Specifically, our provider is a different way of using it compared to the raw Solana example that this project hosted. So we'll just redefine our connection ourselves manually over here. All right, so anyway, we're going to get the provider, and the provider, if you recall from Anchor, is the link to the network that we want to talk to, whether that's local or on prod. And so we're missing quite a bit of things. I'll just paste these earlier. And the first thing we're missing is a wallet. And to get a wallet, we need to use something. We need to use the use Anchor wallet context. This is a big difference between Anchor and the normal wallet. There's actually an Anchor wallet that's defined. So I'm just going to go to import, and from our wallet adapter React, we will just import the use Anchor wallet. And so that will get rid of that red error. And if we're curious, actually, if you hit F12, it'll actually tell you what this returns. Use Anchor wallet would give you either Anchor wallet or undefined. As you see right here, I did an if check to make sure our wallet is not null. It's important, otherwise the compiler will actually complain. So the other two things we're missing is a connection object, and the provider object. So the connection object is from the native web3.js. Here, we can see, we can type, and we can see that connection is an option. So we import that. And provider is actually something from Anchor itself. So I'll just copy and paste all of the imports that we actually need to make. And so there's three things, program, web3, and bn that we're importing that we will use later. I will actually also get rid of the terminal so we have more space. So one thing to know is that we're going to have a red error here, and that's because this is a new package that we haven't imported. So to quickly rectify that, we can go to our package.json, and inside our dependencies, we just type the name of the project, like so. And then once we define a version number to include, Visual Studio Code will actually just give it to us. And so we'll just install the latest version. And that's it. And if we run a npm install again, we'll download that package, and our red squiggly line should go away soon. And there you go. The red squiggly line is gone, and Round recognizes it. And so that's how you install packages. Okay, anyways, so the important part now is our code works. So to quickly go over it, we create our network, and our network is our localhost 127.0.0.1 at port 8899. The reason why we use this is because that's the localhost address that our local Solana network gets deployed to. And so we're just talking to that. Next, we need to create a connection. And so what's interesting if we're curious about this connection is the connection takes in two types. It takes in a string, which is our endpoint, localhost, and it takes in something called a commitment or connection config. Long story short, we're just passing in one of the commitments, which is a, for those not familiar with TypeScript, you can set certain string types to be a type. You kind of think of them as enums in a sense, and process is one of them. So we're just going to use that one. That was also what the examples did. So we put in processed as our type, not as a string, but as a commitment type for those who want to geek out on this. And to create our provider, we just need to pass in three things. We need to pass in the connection that we created, the wallet that we are using, and if we look into our code again, the last thing is a confirm options. And if you look at what confirm option is, you can see that it is a type. The example was a pre-flight commitment, so we use that, and that is mapped to another commitment, which, as we know, is the string. And so a quick way for us to define that object is to just create this JSON object to mapping pre-flight commitment to the processed. Don't worry too much if you didn't get that, just copy and paste this and you should be fine. And so now that we have a provider, we just return the provider and we can use it to actually send a transaction in our later code. So if we save this and actually do npm start, we can see that we launched this and there should be no errors. Yep, there you go, no errors, so we're fine. All right, so back in our code, let's get rid of this again. Okay, so we have set up our provider so we can connect to our Solana network. We now actually need to do something. So the first thing we need to do, let's say we need to implement the 4 instructions that we defined inside our IDL. And that would be initialize, which takes in these accounts. We need to implement update, which takes in an account, and it also accepts an argument. Increment, which takes in this account, and that's it. And decrement, which is also the equivalent. What's also important is to note is that we will be using this metadata to specify the address of the smart contract that we'll be talking with. And to quickly define what we're actually doing with these functions, we can see that each of these accounts has a my account, and you have to watch the past video to kind of get into more depths of this. But my account essentially maps to this account. It's not really an account, it's more like metadata. And this metadata has a field called data. We should have called it something else. It could have been something like counts, for example. That would have been better. And this data type is represented as a U64, which basically means it's just a non-negative integer. And so when I say that we are decrementing, incrementing, or updating, we are modifying the data that we set in this field. Of course, if you want to learn more about what counts are and how they keep track of state for the user on the Solana network. You gotta have to check out some of the past videos. Anyways, now that we have some context of what's happening again, we need to define some UI to actually send a transaction to our network to initialize, update, increment, or decrement. So let's just create 4 buttons. I'll just copy and paste. And of course, if you just clone the Anchor project without following the past video, you'll probably have something similar. I think you'll probably have initialize and increment. So I'll probably indent this. So if we look at the code again, we see we have our 4 buttons. Now let's actually implement the onClick functions. We're just gonna do some sloppy coding. So the first code we're going to create is, all right, so here's our create counter onClick function. We'll use it, but let's go over it quickly. So the first thing is we need to get our connection to the network that we're talking to. Move this out of the way. And we call getProvider. Notice that I call this function async, and that means the code is running asynchronously. And one of the reasons for that is because, and we'll see shortly why, but the quick TLDR is we are calling await on these RPC calls that we're making. They are network requests, and so that is a non-blocking operation. So we just want to make sure that our code doesn't stop everything else from running. So that's why it's async. Anyways, so we get our provider, and if we look at what the get provider code does, remember we can return null. And so that's why we have to double check to see if it's not null. And if it is null, we just throw an error. Now that we have a valid network that we connect to, let's go look at more of the code. So on line 90 to 92 or 91, we create a IDL again. And so the interesting thing I found out about this is that for some reason, if you just pass in the IDL itself, you get an error. And the error is that, there's a lot of errors, but if we dive into what this is. So the problem is that if you go to IDL, the JSON object, and then we look at our arguments, it is complaining that our type that we have right here is a string. And so if we actually dive into what a program expects and see how cool it is that we can just look into the code on VS Code, love it. We see what an IDL object represents. And if we look into IDL, okay, here we go. So this is an actual object representation of our JSON object. So inside instructions, we go to the IDL instruction array. And then we look into the args, which is what I told you the problem was. If we look at what an IDL field is, we see that the type is a IDL type. And as we talked about this before, it's kind of like an enum. We can use a string value like these string like F32 or U64 as a specific enum type or a variable by itself. And so what's happening here is that the code was expecting an IDL type in our JSON, and we were giving it a string, the string U64. So basically how I was able to get around that was that I converted the IDL JSON object that we imported into a string with JSON to stringify, and then I reconverted it back to a JSON. And I don't know what the difference is, honestly, but it works, and the compiler stopped complaining. In our new program, so a program, if we look back into this again, but a program is a client representation of the Anchor program that you created. That's why it's called program. It takes up everything for you to talk to your on-chain program specifically, and that is what we're using it for. So the 3 things that we need for a program is the IDL itself that was generated by the Anchor program. We need the address of our smart contract, which was included in the metadata field. Remember, this is why I told you that we need to do Anchor deploy. And then finally, we need to give it the network that we're trying to connect to, which in this case is localhost. All of this combined with this helper function that we import from the CRM, and we get a variable that can talk to the network for us. And so now, actually inside the try code, we call program.rpc, and RPC is a reference to all of the instructions that we can send, and which in this case is, if we go back to JSON, these 4 things: initialize, update, increment, and decrement. And so if we look at initialize, it actually takes in 3 accounts, which is what we are defining right here. And the accounts are basically the account that you want to store on the network. So that's not defined yet, but we're just going to generate a new account public key every single time that we run this code. We're going to set up the user or pay for the transactions, and then we're just going to give the hardcoded program ID. This is something we need to do on every initialize. Watch the previous video if you want to learn more. And of course, we also need to include a signer. And in this instance, we just pass an array of the accounts we're using, which is just the base account. Once again, don't worry too much about it. Most of this is just copy and paste. So we need to actually define our base account. And to do that is quite simple. We're actually going to set it as more of a global field because we're going to reuse it. And so I'll just paste it up here with our provider. The base account is essentially just a key pair. That's why we get the public key. And inside our Web3, which is the helper library from Solana themselves, or okay, correction, that's from Anchor. We call web3.keyPair.generate, and this just creates any random key pair. I think in production, you might use something like your actual wallet key, or maybe allow the user to put something in. So it's something that they have to memorize. We don't want to generate a new account every single time for the same user. But in this case, that's fine. It's great for testing. We can start off fresh every single time. So we have a base account. This will contain the address to the account that we're going to store on the network. So back into our create counter code, our my account is just the public key of our base account. And then we need to give the public key to our wallet, which we get by calling our provider. Because recall that in our provider code up here, we stored our wallet from our Phantom wallet into this code. So it has access to our wallet address. And then calling the same Anchor library, we just give it the program ID. And then finally for the signers, we also just give it the base account. Like I said, don't worry too much about it. It's just copy and paste. So this will call our initialize function. And what this will do is it will, well, let's see if I can pull it back up and show all of us. If we go back to librs, it will actually call this specific function inside our on-chain code. And what this code will do is it will take the account that you created, which is the base account, which we randomly generated over here. And it will get the data field, which we defined. Actually, we just look down here. This my account type. This is actually what's used to create the IDL file right here. But it will take the data integer that we have, and then we'll just set it to be 0. And since we're here, update, we would pass in a value, and it would just set that value. I believe that's what increment might do if you just clone the Anchor project by itself. Anyways, and then there's the increment, which we just increased it by 1. We don't care what the value is. And then decrement, where we just decrease the value by 1. Also, if we don't care about the value. So that's Anchor. All right. So in this case, we will set our data to be 0, our count specifically to be 0. And then now that it's all on the network, we want to verify and make sure everything is there. The program that we have actually lets us do that. We can query a specific account that we set that is stored on the network, and it's just program.account.myAccount, my account being the data, this, which maps to this account that we're storing on the network. And then we just fetch it. And what the parameter takes in is essentially the public key of the account that we use to create it. And this will give us the account. We print out the account and we see what we get. And if there's an error, we just print out the error. And that's all it does. Hopefully not too complex. And so let's actually use it. So on our onClick, we will just set our callback function to be create counter. All right, so I refreshed it and the Solana code is already reacting. Let's refresh this again. Okay, so I'll back in. So we are in here, and I'm gonna hit F12 to open up my console because we're just printing out the results. And we go to console. We can also debug the code if we wanted to, but we go to console. we're connected. If we hit initialize, we're actually still going to start sending a transaction. So one quick thing before we do that, if this is your first time doing it, you will most likely fail because your network, your wallet does not have any SOL inside of it. So if you want to add a SOL into your wallet, what you need to do is you need to get the address of your wallet. Let's use our multi button. So copy address. And we go into our Anchor project that we had. It doesn't really matter. We just need to go some instance where we set up our Solana node. And we just do, let's move this out of the way. We just do Solana airdrop. Set the amount. I think there's like a hard cap. It can't be greater than 10 or something. So just to be safe, let's just do 3. And then we just paste in the address. And then there we go. We added 3 SOL into our wallet. It's important to note that you might have to do a Solana set config to set your instance to be localhost. Otherwise, it might not work. Yes, I was right. It's a Solana config set --URL and just type in localhost. Never get the camera right. Yep, localhost. So we set this so our commands actually run on localhost, and then we airdrop the token if you failed earlier. All right, so now that we have that, let's go back into our code. We can verify that our wallet has the new amount. Yep, as you see, we have almost 6 SOL now. Very nice. Okay, anyways, so let's try this again. I'm going to just refresh the page. We're going to hit initialize, and then we're going to approve the transaction. So now our front end is sending a connection to the network, and boom, in our console right here. Let's see if we make this bigger. Okay, I can't make it bigger. Fortunate. Oh, I can. Okay. We can see that our account now has data. It's just like a byte array essentially. And if we look up words, this is actually what the byte array represents. What we're really seeing is that the data is set to be 0. I'll show you how to actually read this later. All right, so back in our code. So we have create counter. So let's implement our 3 other functions. And instead of being a good engineer where we have non-duplicate code, I'm just gonna be a bad engineer and I will just copy and paste the code and re-implement everything again. So let's create our increment. Increment is pretty straightforward. Inside our program RPC, we change initialize to increment. We don't need to pass in any of our accounts. We just include the my account type, which is once again defined inside our IDL JSON. If we look at our increment, we see that we just have my account. And we don't need any signers. This is only, if you watch the past video, when you create the account for the first time. To do that, we keep everything else the same. One thing is we'll just call account.data because data is the field that we care about. And we just call toString. And this will convert it to a string that we can read. We do the same thing for decrement. And just get rid of everything. .data.toString. And finally, this one's a little bit different. We have our updates. Same thing, update. We could read a value from our code, but I'm just gonna hard code something. If you've seen the last video, you know that if we want to pass any arguments into our Solana smart contract, because if you look inside our lib again, if we look at the implementation of updates, we have this data variable that we're passing in, and that variable is defined as the first parameter inside our update function. And there's multiple variables. It would be the first and second. The accounts that we have, this whole section is always last. Anyways, so to set the variable, we need to set it in a binary format again. And so to that's where the bn class that we imported so long ago right here is used. All we need to do is inside our update function, we just create a new instance of it, and we say new bn, and we'll just set the value to be 100. And that's it. That's how we pass in the argument. And of course, we clean everything up. We don't need any of this. We read our data and we convert it to a string. All right, so on click. So for the increment on click, we just give it our increment function that we implemented. For decrement, probably should move this higher. And finally, for update, we give it updates. Now this should work. Refresh our page. We hit initialize. And remember, every time we refresh the page, this base account that we create with or generate is always different. So very good for testing. Anyways, so we approve this, create the account, we hit increment, send the transaction. Okay, my apologies. I looked at the code, I found out my mistake. It's too bad it's this late on. I'm not going to edit everything, but I defined the base account inside the create counter function. This should actually be one level higher. This wasn't the global I was referring to. I wanted to put it next to my wallet. And so essentially what was happening is every function I was creating a new key, and that's why we're getting this error where it expected the program to be initialized because this new key we generated was not initialized. Anyways, so let us remove all of this code. All right, now everything should work. Initialize. Increment. There we go. So now we have 1, which is as expected. If we decrement, we send the transaction, it's at 0. And then if we hit update, it should be set to 100. There we go. And just to prove it again, we hit increment again, it becomes 101. And that is roughly it on how you would create a front-end application that would connect to your Phantom wallet. And this is how you use your Anchor IDL.json file to create a front-end application, front-end library that you can use to connect to your network. So probably not as bad as you thought initially if you just looked at the code. Hopefully, fingers crossed. And that is roughly it. If you like this video, I would greatly appreciate a like and subscribe. If you have any feedback or comment about my presentation, I'm always trying to squeeze everything down as much as I can. Please leave them in the comments below. I would love to save both your time and my time. Outside of that, I think the next video will probably look into how we would go about creating tokens and maybe passing them around. So that'll be super exciting. But until then, I will see all of you later.